myself a few cues as we move through these sections to make it a little bit easier to break up the exam. All right, we left off on Monday doing something. I am fairly certain we were doing something. So on Monday we left off, and I said that we were going to talk just a little bit about some of these other issues. I think we went through the static web pages. So if we just go and revisit that just briefly to get ourselves started, right? What I said was if you use this URL lib request module, you can actually treat a static page, right? Something that isn't being generated by PHP behind the scenes, but a static page, an HTML file, you can treat as a file on your local computer. So we can do something like generate a URL. This was our URL for the list of words. We can do a URL open, which is the same thing as conceptually as opening a file on our machine. And then we can do something like while or for line in Word file print, what was it, line .decode? Line.strip.decode, I think, is what we're using. And when we run this, up until it decides that I'm just being abusive, right? This will just give us all of the words in Word file. And by the way, I'll throw in flush equals true. And let's import time. And let's do a time.sleep 0.1. We'll sleep 1/10 of a second so we just don't bomb this thing. And then we'll see that we go through and we print out all of the words in the English language, at least all the ones that are on the page. Think Python, green tea press, think Python, code, words.txt. All right. So the point here was just to show you that there are lots of different types of data and lots of things that behave as files. When you get into operating systems, you'll see that this kind of concept, this model works on a lot of different types of things, reading from your keyboard, reading from a file, reading from another device, etc. I hope I am recording. Let me see. Yes, I am recording. Excellent. All right. Just one more thing. Let's just take out this flush equals true. And what I want you to notice is that this is much more static, much less smooth. Right? You see how it kind of starts and stops. That's because it's bursting out multiple lines at the same time, and then not going smoothly one line at a time. So if we can read a lot of different things as files and we can get our data in, and by the way, we can just print out the line, but what we're going to find out is that the line isn't what we expect it to be. It's close, but it's not exactly what we expect it to be. It's going to look something like this, right? So it has the /r's and /n's because it was generated in Windows format. So it has our line feeds, and then this B colon says that it is in binary form instead of in character form. The strip gets rid of the /r/ns, and the decode decodes it from binary back to a string. So that was purely for showing you how the words looked. The strip and the decode. The data is just the data, and this would just be like reading from a file. These are essentially in a file that's stored on the ThinkPython website. All right. So I said when we have data, the other thing we need to know is one, we have to know how to get it. And I've just showed you, we can do it from files, we can do it from databases, we can do it from HTML. But the other thing we need to know is we need to know how the data is stored. And and the whole process of taking data on the disk and making sense of it based on how it's stored is a topic called parsing. We're not going to get into this a lot. I just did want to point out quickly a few different parsing formulas or a few different structures, definitions of different types of parsing. Python code itself is a parsed format, so you can see that for Python code, we have a line of code. It's terminated by an end of line marker. Blank lines are ignored. Special lines like fors or loops that have blocks underneath them, the block is indicated by an indent. So there's a well-formulated, and modules, right? You have the module name, then you have a dot, and then you have the function or the data, the function you want to call or the data you want to use. So Python is a well-formatted language, and parsing Python is part of why you guys keep having problems when you use things like f-strings. We have to parse that in order to determine whether we have to parse your Python files on Submiti to determine if you're using the correct, if we tell you don't use a for loop, we have to parse the file to see if you're using a for loop. If we tell you have to use a function called move Pokemon, we have to parse the file to find move Pokemon. Most of the time we're doing that correctly. Every now and then you guys find a structure that we can't parse, and you cause an issue with the static analysis. F-strings are the one that comes to mind the most. But every computer language has a well-defined structure that has to be parsed so that we can tell the computer, so that the computer can figure out what it is exactly that we want to do. Other parsing formats you may be familiar with, HTML, the hypertext markup languages used in web pages. That's a nicely parsed format. We'll take just a little look at those. JSON, RDF, Resource Description Framework. Most of these, if they're a well-known format, most of them have modules that implement them, and you can get them as a Python module. Particularly what we'll use in some of our examples and some of our labs, I believe, is the JSON parser. So these formats are things that are widely understood and that are widely used. Let's see. I talked about Python code. Here's an example of HTML code. This is nicely structured HTML code. It looks like HTML code. Right? If we pop it into, I haven't tried this. Let's see if we can pop this in. We will pop this into something. We'll call it, save it out as, nope, that was the open. Test.html. Okay, and now if we go in, with any luck, I should be able to, it's under. Okay, so when I open that file, right, it says basically The title is HTML example for CSCI at 100. Should say 1000 or 1100. Don't know how that happened, but that comes up here in the title. Now we have a body page, and on the body we say things like this is a page about Python with a reference to Python. It contains links and other information. That's the body. So this is a nicely formatted Python page. It has links. All of these are part of understanding and parsing the format, is being able to understand these things. HTML has delimiters, so this delimits the start of a page. This delimits the end of the HTML page or the HTML file. This is the start of the header. /head is the end of the header. You'll see like title is the same, title / title. So this is the start of something. This is the end of something. So when we're going through, we can actually parse. You know, when we hit this, we know we've started a body paragraph. When we hit this, we know we've ended a body paragraph. It is kind of interesting that despite the fact that that looks very pretty and is probably the way you want to format it, the tags are actually what matters. None of the rest of this actually matters at all. And we can get rid of all of it and put it on one long line. And if I were faster, I would be done talking about this. Right, so you can have just one long, ugly line of code, HTML code, and that actually doesn't matter. The page still looks the same, still renders the same. The information is all encoded in the sequence of start and end tags, and then the information inside. Okay. I see there's a question on Lecture 14 exercises. This is not a traditional class. 14, I should have mentioned earlier, is our catch-up. I think I did mention it. It's one of our catch-up lectures. What we do here is we can go through material that we've missed or that needs to be addressed, but it also gives us an opportunity to take some time. We'll take at least 30, 40 minutes just to talk about some design and how to go about defining your code and how to get started on doing code today. Once we've just finished up with these parser formats a little bit, just so you get exposed to all of this material. Okay, so and here we go. Here's the busted up version. So HTML is freeform. The parsing, the division of it into significant elements is accomplished through use of these start and end tags. One cool thing, I talked about JSON a little bit. JSON is a JavaScript object notation. It's a way that data is frequently passed on the web. It's a lot like HTML in that you have this start tag, which is a curly brace, an end tag, right? A start square bracket to denote a list, an end square bracket. The interesting thing about JSON is, well, like I said, if you have a common format, it's frequently the case that there's a module for it in Python. We will actually use the JSON format. I think we already use it in the Yelp lab, although I think that was hidden from you. But you can do an import JSON that enables you to do JSON reads to and writes from JSON. Now if we have this X, you'll notice that X looks an awful lot like a string, or like a list, right? It looks like a list whose first member is A, and whose second member is another list, B3. But in fact, X is a string, right? We can use our JSON module. This is actually a string in a JSON format. We'll get into more complicated formats, more complicated JSON strings when we talk about dictionaries. But for right now, we can do JSON.read. I think it's read, right? No, JSON loads X. And what that does is it takes this string, this X string assumes it's a JSON string and then converts it to the appropriate Python, appropriate Python. So we'll say L equals JSON loads. L is now a list, and that's a list with it's a list with two members. L0 is the string A, and L1 is another list, B and 3. Okay? What else do we want to talk about here? I think the other one we want to talk about, and this is in relationship to your paragraph module. You've already run into this when we were parsing difficulties of paragraphs. Basically, that's called an ad hoc data form. Well, not really. You use some of these same techniques when you're doing that. But if you've used spreadsheets and other formats where you've had something like a comma delimited, a CSV file, comma separated values, or where you've had to break things up based on the Yelp data. We had a list. One of the list entries was this address, and the address was separated by a plus. So these ad hoc formats are just kind of formats that somebody's thrown together to encode their data, and the parsing is the effect of decoding them. So, what you have to do when you go through those is you have to know what the format is. So, for example, if we have a file, or we have a file of comma separated values, maybe where chicken noodle, different types of soups, and how many cans we have. Maybe what we want to do is we want to transform this into a list. Let's say S equals 1, 2, 3. Control V. Did I not get those? Yeah. Right. Maybe we've read from our file 2 lines for chicken noodle and clam chowder. The first thing we would have to do is we would have to break this on, we'd have to split this on the /n's to get the 2 lines of the file, maybe. So we can say something like S equals S dot strip. Notice I'm doing a strip to get rid of the extra /n at the back end. S dot strip dot split, and we'll split on the /n, right? So that should give us a new S that is just chicken noodle soup, comma 2, clam chowder, comma 3, and now maybe we want to go through and we want to say for L in S, we want to go through each line, and we want to parse out the line and find out the type of soup and the number of cans of it we have. So maybe we want to say for L and S, L will first be chicken noodle 2, then it'll be clam chowder 3. So we want to do soup equals L dot strip dot split on the comma, right? So now we're going to break that off. Type equals, let's say T equals soup sub 0, right? This will be the first element of that stripped list. That'll be, for example, chicken noodle. And I think we're going to want to strip that to get rid of any extra characters. Num equals int soup sub 1, and we'll strip that again. We probably don't need to for that. Okay, and now we can come in And if we wanted to, for example, we could just print num times t. That should give us I'll put a space after the t. Right? This should give us, when we have 2 cans of chicken noodle, it should give us chicken noodle twice. When we have 3 cans of clam chowder, it should give us clam chowder 3 times. And if we wanted to, we could put this into a list. I think that's what we show. So instead of printing, we could actually go through and do something like I'm not sure I have this syntax exactly right. I didn't. And of course I don't. Okay. Almost. Have to work on that a little bit more. But the idea is we could use that number and that type to kind of pull it out. I don't want to spend a lot more time debugging something that I didn't actually expect to tell you guys. But so that's kind of what formats are all about. It's from taking something that's in a specific format on the disk or on a web page and parsing out the data so that we end up with something. This is what I was going to come up with, but we're pretty close. One more try. All right, so if we start with a clean L, that will actually do it. I was trying to get away from having to do that second loop, but I'm sure there's a way to do it. I just am blanking on it right now. Okay, so that's the example in the sheet. So that's the idea is that parsing, if you know the data format, you can start pulling the data format apart and actually extracting data from it, like how many cans of soup you have and what your pantry shelves look like. It has a bunch of chicken noodle followed by even more clam chowder. Apparently nobody likes clam chowder. At least that's the way it goes in my house. The ones we have the most of are the things that no one will eat. Any questions? We have any issues here? Otherwise, we'll get on to actual lecture 14 with no lecture exercises. You get a break tonight. I think I should put up my little sign saying this is a good time to break.